itself is quite heavy, and I will try to make it as light as possible. This session probably focuses on two issues. One is the factor analysis, and the factor analysis can be primarily categorized into two areas. One is the exploratory part, the exploration, the EFA, and then after exploring it, we need to confirm it. So the confirmatory part, the confirmatory factor analysis. So we normally say that now one part is the EFA, the exploration of the factors, and the identification of the factor structure, and then confirming or validating that particular factor model. So in the first case, when we conduct an EFA, we normally identify the factors, and in the second case, when we confirm, we actually confirm and validate the measurement model. So I will just go through some very basic ideas of what factor analysis is, particularly the EFA part, and if I get time, I will touch upon the CFA. I will just go through, run down this particular slide. Let me just share my screen. Is it visible? Any one of you can respond?
Yes, sir.
Okay. So just going through it now in statistics. Apart from various methods, we can primarily identify two very important techniques, or two very important methods. For example, one is one is basically the dependence technique, and the second one is the interdependence. So when it comes to the dependence technique, there is an identified set of independent variable and a dependent variable. Okay, so if we conduct the normal regression analysis, or say if it can be simple regression analysis or a multiple regression analysis, so there we have a pre-identified set of independent variable and say a multiple number of dependent variables. So we can apply various regression techniques. For example, simple regression analysis, if we have a very simple kind of relationship to be explored, we can go for multiple regression analysis if the model becomes quite complex. And if it becomes more complex, we have the hierarchical regression, the logistic, multinomial logistic. So lots of options are there. But the main issue is there we have a set of independent variable and a dependent variable. Say, for example, production of crop, or say yield of crop. Okay, so if this is a dependent variable which is identified, and probably we are trying to find whether rainfall is having a significant influence on this particular yield of crop. So here the rainfall is basically the independent variable, and the dependent variable is the yield of crop. Now, okay, say rainfall is the first independent variable. Now we as a researcher, we may postulate that it is not only rainfall that will have an impact on the yield of the crop. There may be another one which is called, say, the quality of the seed. Okay, so now we have two independent variables which might predict or forecast the nature or the quality of the yield of crop and the quantum of the yield of crop. And then the researcher might be very interested to throw in the picture another independent variable. So the researcher is basically expanding this particular equational framework. So he or she is interested to see the nature of soil. Okay, say the soil texture or the quality of the soil, whether it is also having an impact on the yield of the crop. So in case of a dependence technique, we have a identified independent variable and a dependent variable. But there can be certain situations where this concept of independent variable and dependent variable may not exist. So those areas are dealt under this interdependence technique. There is no, pre-identified dependent or independent variable. Now, therefore, in this particular case, these particular cases, what we need to identify, either the factors which are responsible for certain phenomena, or we have certain observed variables, and we do not know whether these observed variables can be, unified and can be integrated to form certain dimensions. Now, these dimensions are obviously latent. Latent means they are unobserved in nature. Okay, for example, in our day-to-day life, actually, we conduct factor analysis without knowing the fact that we have actually done a factor analysis. Say, for example, since we are teachers, most of us are teachers. As a teacher, when we conduct a student profiling, okay, suppose I am conducting a student profiling on the basis of certain behavioral characteristics of the student. So I enter into a class and I interact with the students for at least, say, a month or so. Then I focus on a particular student, say A. And over a period of 1 month, while I interacted with that particular class, I found that this particular student is very shy. Okay, that is one of the behavioral characters. Very shy. That means he doesn't, mix with other people. He talks less, doesn't interact with other people. Probably there might be certain mental blockages or certain kind of inhibitions that is acting on him or her. Doesn't participate in group activities to that extent. Restrict himself, or you can say limits himself to one corner of the classroom, doesn't have a very good rapport with the classmates. So all these behavioral aspects a teacher has noticed for at least, say, 1 month. Okay, now this particular teacher is drawing a conclusion about this particular boy. And this teacher is drawing a conclusion about that boy, that this boy is extremely introvert. Okay, fine. So this terminology, introvert, this cannot be directly measured. Okay, we do not have any kind of a scale with the help of which this introvertness, or even if I take the opposite, behavioral dimension of introvert, that is extrovert, that also cannot be measured directly. So there has to be an indirect mechanism to measure this introvertness. Okay, so what is that indirect measure? I need to observe certain characteristics. I need to observe certain behavioral manifestation of a particular student to allow me to reach to a conclusion that this particular student is either introvert or extrovert. So in this case, I have studied this student for a period of 1 month, and these are the behavioral manifestations. So behavioral, and when I say it is manifested, that means I have observed. So I have observed that he is a bit shy, he talks less. Okay, he just restricts himself, he doesn't participate in the group activity very spontaneously. So all these observed characteristics have allowed me to reduce these number of variables into a single dimension or a single factor, that is introvert or extrovert. If the opposite characteristics were noted, obviously the teacher would have concluded that the student is an extrovert kind of a student. So you see, this is a very simple example, and as a teacher or as a person, we used to do, isn't it? We actually perceive a person on the basis of certain characteristics of the person. We often attribute a particular kind of a character or particular kind of a nature to a particular person based on certain observed behavior of that particular person. So knowingly or unknowingly in our social behavior, we conduct factor analysis day in and day out. Okay, the only issue is okay, we are not statistically validating or statistically computing that particular, relationship between the observed variables and the kind of interpretation that we are making in terms of assigning a latent or an unobserved dimension to this observed variable. So very simply putting, factor analysis, or to be very specific, the exploratory factor analysis is a technique with the help of which we can reduce a huge number of variable set. Sometimes what happens, a researcher tries to develop a scale. Okay, now, while developing a scale, if the scale doesn't have a historical presence, that means a particular researcher enters into the literature review and the researcher did not or could not find any reference or good citation about the scale that he or she is perceiving and desire to design, then probably he has or she has to collect a number of scale items from different sources. Okay, and even if there is a historical presence of such kind or similar kind of scale, which was used in a different context, which was used in a different pattern of study, that particular scale may also be adopted with induction of new observed variables or new kind of scale items. So in that process, suppose a researcher has developed 150 scale items, okay, to define a particular scale. Say, for example, let us take a very real life example. Like in the year 1985, three-person, Parashuraman, Zitham, and Berry, they developed one scale. Normally, it was called PZB scale. The scale is about service quality. Okay, how to perceive the quality of a service? It's a really difficult task because service is something which is very intangible, cannot be seen, and how to perceive the quality. So initially in 1985, they started with 128 scale items. So scale items means the variables that they felt at that particular point of time will be required to define that particular scale. But 128 variable is a massive data. Okay, and for a particular researcher, it must be very difficult to actually use that 128 variable and give it a kind of a shape that may be interpretable. Okay, and subsequently when I shall be using the scale, and if it has all those 128 variables, and if I want to use that scale for practical use to collect certain primary data from the respondent, a particular respondent might not feel interested to respond to all those questions pertaining to 128 variables. So a primary survey will be very difficult to conduct. Now, this is number one. And number two, I am not sure that all these 128 variables, whether they are whether they can be clubbed into a single. Say variable number 1 to variable number, say, 6. These 6 variables probably they try to generate same kind of response from the respondent. So if I keep 1 to 6, either there will be a very ambiguous response or there will be no response, because the respondents would find that there is hardly any difference between what the researcher is asking with regard to variable number 1, 2, 3, 4, 5, and 6. So either there will be a ambiguous kind of a response or no response. In that case, the primary research will be incomplete and there will be a lot of missing data. So our objective, or the researcher's objective, will be, okay, let us put these 128 variables in a particular process to find out, can I reduce the number of variables? This is number one. And number two, can I find out the underlying factor structure that has all the reduced number of variables in a particular form? Okay, so variable number 1 to variable number n. So here n is equal to 128. Say factor number 1 to factor number n. I do not know how many factors will be required to actually accommodate these number of variables. So my or the researcher's objective is these huge pool of variables are to be reduced, and we need to find out what is the underlying factor structure or the hidden factor structure that actually accommodates these variables. Okay, so in an exploratory factor analysis, you will find you must have come across a particular term called factor loading. Okay, factor loading means whether these variables are loaded significantly on certain factors, say f1, f2 up to fn. So when I am putting a value, say 0.706, what does this mean? That this is nothing but the correlation between this particular variable and this particular factor. So let us come to the basic concept. Interdependence technique you have already understood. And so factor analysis basically is an interdependence technique whose primary purpose is to define the underlying factor structure among the variables of the analysis. So what we are supposed to find is, say, for example, let us go back to the earlier example that I've given. 128 variables. Can I reduce it? Okay, so it is a kind of a data reduction or a data summarization process. Number one, so this is objective number one for factor analysis, reduction of the data. And number two, can I find certain factors, okay, whereby these variables can be attributed for. Okay, so my objectives are two while conducting a factor analysis. One is reduction of the data and reducing it to manageable proportion. And number two, to identify the factor structure or the dimensional structure that is mainly responsible for articulation or arrangement of such number of variables. Okay, so later on what we can do is, after identifying that factor, we can proceed for the dependence technique. That means we can go on and conduct the regression technique after identifying the factors. Okay, so one of the preliminary requirement to conduct a factor analysis is, suppose we have 128 variables. Preliminary requirement, there has to be a high degree of correlationship between the variables. But when they are extrapolated into factors, factor 1, factor 2, factor 3, factor 4 up to factor n, these will be in zero correlation with each other. There should not be any kind of correlation. These will be independent dimensions or independent factors. Okay, so this is the purpose of factor analysis, to simplify the data. And we basically want to reduce the number of data, and we want to find out the factor structure. But along with this, probably you have come across another terminology, which is called the PCA, the principal component analysis. And sometimes there is a question that exactly because the techniques are same and the motivations of the objectives are same, that when PCA is used, they are also being used with an objective to reduce data. Now PCA basically, you can say the first step in conducting a factor analysis. The PCA basically focuses on just reduction of the data, or the reduction of the number of variables. So they will just compress the data. With the help of a PCA, we are actually not interested to find out what is the uncorrelated factor structure, which is the objective of the factor analysis. Okay, and both these techniques, this EFA and PCA, they basically emphasize on the variance. Okay, now when PCA uses its own method, they reduces this number of variables, say from 128, it is reduced to say 50. How the reduction is done in the PCA? They use the common variance factor. Okay, so on the basis of the common variance, they apply a technique and reduces the data. The machine algorithm takes that particular input and the common variance, and they reduce the data. But in case of factor analysis, it's not the common variance. It's basically the unique variance plus the shared variance or the common variance and the error variance. All the three criteria, variance related criteria, they are taken into consideration not only to reduce the data or to summarize the data, but also to find out the underlying factor structure. So I will just go through this one. This will give you a certain idea. We talked about these dependence methods and independence methods. Say number of dependent variable is none. That means number of dependent as well as independent variable. If it is none, then we go for interdependence methods. Factor analysis is one of the interdependence method. We are going for factor analysis. We are going for clustering. We are going for perceptual mapping. All those, people who are working in the corporate sector and they are going for brand management, they actually use this perceptual mapping a lot. Perceptual mapping is basically a grid-like, matrix, and it is normally used with two major dimensions, X and Y, with say, dual subdimensions. Okay, anyway, that's a perceptual mapping, and we are concentrating on this, the factor analysis. Okay. Now, if there is a dependent variable, say the identified set of independent and dependent variables, as I have told you. So it is the dependence methods. And in the dependence methods, the level of measurement becomes very important. Now, what test you will apply? So if you are dealing with nominal data, non-metric nominal data, you are supposed to conduct, say, a discriminant or a conjoint analysis. If you are focusing on multivariate analysis, if you are using an ordinal data, you can go for a rank correlation, particularly to find out the Spearman's coefficient. If you are using a scale data, say interval or a ratio, that's the metric data, then you can go for, regression techniques, multiple regression. You can go for ANOVA or MANOVA, or even a conjoint analysis can be done over here. So it really depends on what is your objective as a researcher and what kind of data you are handling. Without having, proper knowledge about the kind of data that you are handling, it's very difficult to make a conclusion what kind of a test you will be applying. That is number one. And number two is what is the objective of conducting such test. In this case, what we are discussing for factor analysis, our objective is very clear. As far as the data is concerned, we do not have a clear-cut indication of the presence of an independent variable or a dependent variable. So we are crossing this option out. That means dependence methods cannot be applied, opting for an interdependence method. And in an interdependence method, we are not going for analysis of any classifications. That means we are not going moving into identifying clusters. So we are actually focusing on to identify the factor structure, underlying factor structure, or the latent factor structure that can be attributed for the distribution of the reduced number of variables. So our objective is pretty clear: reduction of the number of variables that we are working with, and to identify what are the factors or dimensions that can be attributed for those reduced number of variables. So this has been clearly stated for what this factor analysis is used, and the principal component analysis. I will share the slides with you. And there are certain, what should I say, criteria to identify how many factors are to be retained, how many factors have been extracted, and what is the interpretation. So we will just go on to hands-on to see how this factor analysis is actually conducted. And this concept of rotation I will take up once this hands-on is progressed. So let us open one SPSS file. Say I have a SPSS file with me. Now, very few of us, very few university, in fact, or colleges, they have a licensed version of SPSS. So a number of scholars they ask, is there any alternative to SPSS? So there is an open source software which is called PSPP. It's almost like an acronym to SPSS. PSPP basically it does all the activities or all the calculations, all the statistical operations that can be done by SPSS. But only disadvantage of PSPP is the interface. It is a black and white kind of an interface, so it is not as glamorous as this SPSS is. But it will do every activity that you can perform on the SPSS platform, and it is an open source software, so you can easily download it and install it in your machine. So if you do not have access to SPSS and all the modules of SPSS, you can easily use the PSPP. Okay, so this is a file of a specific. Let me just give you an idea of the relationship that we are trying to explore here, so that it becomes easy for you to interpret. I will just take a blank slide. This is the theoretical posit, the theoretical postulate based on which the data has been collected. We are very much interested to know that whether mobile application use of mobile application, they have anything to do with attachment with brands. Okay, consumer attachment or consumer affinity or consumer association with particular brands. So this is the relationship that we are trying to assess, but we are not sure about the factors which are responsible or the number of variables that should be included in the scale. So we have done, we have put the entire pool of scale items on factor analysis. Now, we are also interested to identify whether experience with certain brands or brand experience of the consumer, they have certain kind of impact on this attachment, and whether mobile application usage has certain kind of association with the brand experience, whether this will have an impact on the brand experience. So if you see, if I consider this as a variable 1, this actually will be the factor 1, which will be reduced after the factor analysis being conducted. This is V2 and V3. This is the theoretical model that we have developed. Okay, this is the theoretical model that we want to test. Okay, so there are 3 sets of interaction. MAU having an impact on this. This is the null hypothesis is and that MAU does not have any impact on this. MAU does not have any impact on brand experience. Brand experience does not have any impact. But interestingly, there is a mediation effect that we will consider later. But initially, this is the theoretical model. Now, before going for a test of this particular model or the hypothesis, we want to, identify the actual scale that has to be used for collecting our data, the primary data. As a result of that, we are conducting this particular factor analysis. So let us go to the data. Now, you see, these are the numeric data that we have collected. These are the scale data, as you can see. And if I come to the variable names over here, apart from the demographic factors, these from M1, M2, M3, these are the scale data. Now, what is M1, M2, M3, and M4? These are the 4 variables that has been used to scale the mobile application usage. We do not know whether all the data or all the variables will be included in our factor structure, but we have used 4, you can say, items, or you can say 4 behavioral items, 4 statements which are actually describing the usage of mobile applications. Similarly, In case of brand attachment, what we have done, we have used 9 items or 9 variables. We have identified 9 variables from various literature review, various pilot study. We have identified that there can be a maximum number of 9 variables which can be used to actually identify whether they are loading onto they actually define the brand attachment. Okay, so 9 items, and these L1, L2, and L3. This define loyalty status. S1, S2, S3. This define the consumer satisfaction status. A1, A2, A3. That defines the attitude status. I can show you another file of SPSS which will give you certain more insights if I am having here. Let me see, that will give you a much more insight. Yeah, you see, this is a model which is a very famous model, which is having a theoretical background called theory of planned behavior. In a theory of planned behavior, there is a set of attitude variable, there is a set of subjective norms, there is a set of perceived behavioral control variable, there is purchase intention, and then purchase behavior. This is a very well established theoretical model of theory of planned behavior. And you can see what is 81? 81 is, this is a statement. I think that purchasing green products are favorable. So we have fit in a particular scale, 5-point or a 7-point Likert scale, with agreeableness to the maximum, with agreeableness to the minimum, say 1 to 5 or 1 to 7, depicting the highest position as well as the lowest position. So 81, 82, 83, 84, these are the measurement of the attitude of the customers or attitude of the respondents. And these are the statements against which the response will be generated. Similarly, with regard to subjective norms, we are fixing 3 variables against which these are the statements against which the response will be recorded. Perceived behavioral control, again, these are the some, you can say, statements against which the perceived behavioral control will be measured. Purchase intention, I intend to purchase green products next time, I plan to purchase. So these are the variables which depict or which capture actually the purchase intention of the customers. And then the purchase behavior, I deliberately purchase green products. That means they are spontaneously involved in purchasing. I always purchase green products whenever I have an option. So these are the actual statements against which this particular response will be generated from the customers. So going back to our earlier file of mobile app usage, now you have probably understood how we have conceptualized all these things. For M1, we have a statement. For M2, we have a statement. M3, we have a statement. M4, we have a statement. And from M1 to M4, we have statements with regard to identifying what the consumers feel about the usage of mobile applications. Okay, to what extent they are using mobile applications, and whether those mobile applications are used with reference to brand search, with reference to identify what kind of brand performances are there, names of the brand which are available in the market. So actual usage of the mobile applications within context or in perspective of the brand availability. Then we have the brand experience, and then we have the brand attachment. Okay, so this is basically the theoretical, you can say, model that we just showed. This is the theoretical model. At the end, we need to identify this kind of a relationship between the latent factors. But to start with, since there are how many? If we see the variable view, we can easily identify how many variables we have taken. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So this is a separate one. So 27. 27 variables are there. Now, as a researcher, I am not comfortable with 27 variables. I want to reduce it because I do not know whether all the 27 variables are valid variables to measure the underlying factor structure. Okay. Now, here comes another question that almost all the researchers they used to ask is, while conducting a factor analysis, what will be the sample size? Okay, that's very important because there is a rule of thumb. It depends on actually what you are surveying or who are the ultimate respondent. What is that rule of thumb? The rule of thumb says that if you have say 20 variables, in this case, in this particular case of mobile app usage, we have 27 variables. So if we have 20 variables, the number of respondents should be multiplied by 10, that is 200. Okay, and the minimum should be, if you want to have a very robust kind of a model, the minimum should be number of variables into 5. So 5 times the number of variables, that is 100. Okay, and to have a very robust kind of a dynamic model and a very vibrant model, there should be 10 times the number of variables, that is 200. So you can easily imagine, if you increase the number of variables, say from 20 to 50, you require almost 500 as a sample size. Then that is quite staggering, and for most of the researcher it becomes very difficult to conduct research with 500 sample size. Okay, but if it is an individual customer, then this is probably quite good. 10 times that of the number of variables, or with a minimum value of 5 times that the number of variables are. But certain researchers may be very interested to conduct their research on B2B sectors. B2B sectors means where the industry, basically the industries or the organization are your respondents. Okay, so obviously you cannot conduct the research over 200 organizations or 500 organizations. So there, only in B2B sector, this rule of thumb is not applicable. There you need to find out, since in B2B sector we are dealing with a finite number of population, so we know how many organizations are there in a particular industry. So the sample calculation on the basis of standard deviation is quite easy. So there the sample calculation may be made on the basis of the standard deviation. We can find the sample size, particularly for the B2B sector. Say in the TV sector, in the TV industry, suppose there are 25 companies operating. So we know the population size, and then we can identify the number of samples that will be required to conduct this factor analysis. But in this case, where I am dealing with the mobile app usage, I have 27 number of variables. So obviously I need to cater to 270 number of sample to make the model very robust. So in this case, you will find that I have taken 169. So since this is a sample case, probably it will hold good for demonstration. But this is actually, this should not be followed. At least 270 sample should be taken. However, the minimum sample size that we talked about, that is 5 times the number of variables, it has crossed that. So let us just stick with this and conduct the analysis. So in the Spss, since we all understand that you are conversant with this SPSS package, so for factor analysis, we will click analyze. Okay, and we can go for this particular option called dimension reduction. Okay, because that is the objective of factor analysis, dimension reduction. We will straight away move to this one called factor. Okay, now from the left hand window, we need to pass on all the variables for which we want to conduct the factor analysis on this variable window. Okay, so for all the scaled data, say from M1 right to BA5, Okay, we are just shifting it to the variable window. So all our scale data or metric data that has been shifted to the variable window, and this entire scale item has been put forward for underlying to identify the underlying factor structure. So let us now fix up all the optional area, the descriptive. As far as the descriptives are concerned, certain boxes are to be ticked. One is this KMO. I will explain what KMO is. KMO is basically the Kaiser-Meyer-Olkin test and the Bartlett's test of sphericity. They have their own objective, why these tests are to be conducted. We need to find out the coefficients, the determinant. Sometimes we need to report this anti-image also, but it is not mandatory to conduct the anti-image. Anti-image, basically it's the mirror image of the correlation. So obviously the mirror image of the correlation, sometimes it is required, but in major cases this is not reported. If you see the journal papers of good journals, you will find most of the EFA reportings are not done in a very tabular kind of a format. It used to be done earlier, but nowadays the EFO results are simply specified in a text format, in a paragraph, and the results which are represented in a tabulated formation, that is the CFA results, or the confirmatory factor analysis results, which actually validates the EFA results. So over here, you can take the univariate descriptives also if you want to check out all the univariate descriptive, but we are more or less interested to know about the KMO and this Bartlett's test. So just click continue. Come to the extraction. In extraction, we need to find out the scree plot. This scree plot is one of the graphical representation of the factor analysis output, based on which we can identify the number of underlying factor, or we can have an idea about the factor structure. Based on eigenvalues greater than 1. This is a latent criterion route to fix eigenvalues greater than 1. So all the factors which are loaded on an eigenvalue of greater than 1. So eigenvalues basically represents the amount of variance in all the items that can be explained by a given principal component or a factor. So normally it is put at 1. I will talk about one more thing that is used while reporting the factor analysis in the journal paper. That is called the common method bias, or CMB. How to find that? There is a test called Harman's test. I will just show you, because for that you need to tick this. Okay, but for the time being, we are focusing on this. We are focusing on the latent criterion route to find out the factors. So continue. So here two factor, by default it will be checked, and you need to check this scree plot. So continue. Then comes rotation. Okay, I will explain what rotation is all about. Here we need to click the Varimax. Okay, and then we will continue. Because there are a lot of rotation option, like Varimax, maximization of variance. There is Promax, Equimax, and basically since we are going for a orthogonal kind of a rotation, not a oblique rotation, we need to click on to the Varimax. But the concept of rotation has to be made clear, and that we will take up after this. Then the scores, we need not do anything over there here. And options, you see, in options you can apply one thing, sorted by size, and suppress the small coefficient. Actually, we since the loading factor or the coefficients are the correlation coefficient between the variables and the identified factors, so we need to put up a good coefficient value to make the measurement model very robust. So normally it is put at 0.60. Any factor loading over and equal to 0.60 is accepted as a very robust kind of loading. But if you want to make your model much more precise, much more robust, much more authentic, you can just put a higher value, say 0.70. then we will go for continue, and then we will click OK. Now, before just clicking OK, let me go back once more over here. See, I have clicked on suppress small coefficient. Okay. If I do not suppress the small coefficient, then all the coefficients will be loaded. Okay. So all the coefficients means the coefficients that I did not specify. Below that, say I am specifying 0.70. So if I am not, suppressing the small coefficient, the entire range of coefficient will be loaded. Okay, so continue and then place OK. Now, this is the output result. So we clicked on to the descriptive statistics. This is the correlation matrix. And initially, this correlation is because we have said one of the preliminary assumption to conduct a factor analysis is there has to be a very high, correlation between all the variables. That is the preliminary requirement. So you can see between M2 and M1, it's 0.727. It's a very high level of correlation. So you can see the diagonal values. Okay, 0.216, not that significant compared to that of 0.740, but still it is significant. So the correlation matrix will give you certain preliminary idea whether all the variables are having good correlationship with each other, all the variables. Now here comes the first interesting part. The first one is the 0.861 value. Now, what is basically KMO? Now, a KMO or the Kaiser-Meyer-Olkin, this particularly the full form of that particular abbreviation, the KMO is a measure of KMO. Basically, it's a measure of sample adequacy. Okay, and normally the KMO's value is taken as 0.70. So anything greater than 0.70, sometimes it is also taken as 0.60 also. We have seen a lot of journal papers which has reported the KMO value as 0.60 also. But to make your sample which you have used to conduct the factor analysis absolutely fit to conduct the sample adequacy, it should be greater than 0.70. So in this case, you can easily see that KMO value is 0.861, which is well above that rate of 0.70. And then there is a Bartlett's test of sphericity. Bartlett's test of sphericity, basically it gives out the chi-square result along with the degrees of freedom, and we have a certain significance. The significance, again, what does this Bartlett's test of sphericity signify? Now, it rejects basically the null hypothesis. The null hypothesis is basically is the matrix that we have, the correlation matrix that we have is either an identity matrix or a singular matrix. Now, in both these cases, if it is, say, from ranging from 0, the extreme value, the correlation, to 1. So if it is an identity matrix or a singular matrix, then probably the data is not amenable to factor analysis. So the data is not fit for conducting a factor analysis. But here, what we have received a significance value of 0.000, which is basically what? The significance level is the p-value less than 0.05. Okay, so we can reject the null hypothesis, which assumes that the data is either an identity matrix or a singular matrix with extreme value of correlation. So if we are rejecting the null hypothesis, then we are accepting the alternative hypothesis that the data is fit to conduct the factor analysis. Now, these two results, the KMO result and the Bartlett's test of sphericity, these two results are to be reported whenever you are writing a journal paper and you are conducting a factor analysis. The KMO and Bartlett's are to be reported. So KMO basically refers to sample adequacy. That means to conduct the factor analysis, we have collected enough number of sample. Okay, so if the KMO value is greater than 0.70, and if it is greater than 0.8, in this case it is probably 0.867, it is a very good KMO value, which approves the sample adequacy. And the Bartlett's test of sphericity, it rejects the null hypothesis that the matrix is either an identity matrix or a singular matrix. In those two extreme cases, the data, with that particular data, you cannot conduct a factor analysis. So we have got a p-value of less than 0.05, which is significant enough to assume and reject the null hypothesis and accept the hypothesis, alternative hypothesis, that the data is fit for factor analysis. So that is the preliminary set of values that is required to be reported. So this KMO and Bartlett. Then let us come down here. This is another important area which will give you a preliminary idea how many factors you have actually extracted. Okay. Now over here you can identify that you have extracted actually 1, 2, 3, 4, 5 factors. Okay, so these 5 factors, they attribute, they actually contribute 73.5% of the total variance in the model, and that is quite high and significant. Okay, 73.5% of the variance in the model can be explained by these 5 factors. Okay, and these 5 factors have been extracted on the basis of what? On the basis of eigenvalues being put at greater than 1. Okay, so we have extracted 5 factors which explain the total variance of 73.434, close to 73.5. Now, if you see the scree plot, see from 0 to 12, so we have put a eigenvalue of greater than 1. So 1 will be somewhere over here between 0 and 2. So if we are placing 1 here, then see how many numbers, how many factors have been extracted. This is factor number 1, 2, 3, 4, and 5. So if I draw a straight line over here, let me see if we can fit a straight line over here. Eigenvalue will be 1. Okay, apply. So now you can see, if I put up ab line over here, this is the ab line that starts from 1. So any factor equal and above 1. So this one, this one, this one, this one, this one, 1, 2, 3, 4, 5. So there are 5 factors that are responsible to explain the underlying factor structure in this particular case. So in the total variance explained, you have seen that 5 factors have explained the maximum variance. 73.43% of the variance in the model has been explained by 5 factors. So the scree plot also proves that the 5 factors have been extracted. This is the component matrix. We do not require to report the component matrix. We need to report the rotated component matrix. Okay, the concept of rotation, I'm just coming. So over here you will find again 1, 2, 3, 4, 5. So these are the 5 factors. These are the list of variables. Okay, we started with how many? We started with, probably you can recall, 27 variables. Okay, now we have put a loading value of 0.7. You can remember that any loading value of 0.7 and more it will be only recorded. So you can see in all these loadings, what is this loading? This loading value is nothing but the correlation between variable and the factor. Okay, so this is a correlation value or the correlation coefficient value between S1, this is the variable, S1 variable, and factor 1. Okay, then this is the correlation value between S2 and factor 1. This is the correlation value between L3 and factor. So all these variables. So we started with how many? We started with 27 variables. And now, after the factor analysis, let us see how many variables have been retained. So in factor 1, 1, 2, 3, 4, 5, 5 variables have been retained. In factor 2, 1, 2, 3, 4, 5, that's 10 variables. In factor 3, 1, 2, 3, 4, that is 14. In factor 4, 1, 2, 3, that's 17. And 2 in factor 5, that is 19. So we started with 27 variables and we have reduced it by conducting a factor analysis to 19. So 8 variables, and the variables you see which did not have a significant loading, like BA1, L2, and BA3. These 3 variables did not have any significant loading. Then B2, B1, they did not have any significant loading. Okay, B4, B5, they did not have any significant loading. They did the B2, they did not find any factor also to be loaded significantly. So 9 variables were excluded from this particular model, and only 19 variables were retained. Okay, 19 variables. So 8 variables were excluded out of 27. So we have reduced the number of variable to a manageable few, and we have identified the underlying factor structure. So the 19 number of variables can be attributed to these 5 factors. And what the researcher should do now, based on what kind of variables have been loaded, they will name these factors. The nomenclature of these factors has to be done by the researchers. Okay, so based on what kind of variables have been loaded. Now, we were talking about one issue called rotation. So let us go back to the data file again, to analyze, to dimension reduction, to factor. So over here, you see, we have opted for a varimax rotation. Fine. So let us continue with this. Let us go to extraction. Eigenvalues greater than 1. Let us stick with that also. Let us go to scores. No need to change. Let us go to options. Okay. Now I am just withdrawing this suppress small coefficient. I'm just withdrawing this. Both the things, sorted by size and suppress small coefficient. I am just going for continue and okay. Fine. Now come to the results. Okay, so we have already seen the KMO and the Bartlett's test. It remains same. The results remain same. The result will not change. The total variance explained also 73.434. Okay, the scree plot stays same. This is the component matrix. This is the rotated component matrix. Now, in this particular matrix, there are certain important issues that you need to find out, or you need to address. Okay, say for example, this particular variable. Okay, this particular variable is loaded with 0.607. This is the value. It has been loaded to factor number 1. So the correlation factor is 0.607 between L2 and factor 1, F1. At the same time, the correlation value between L2 and factor 2 is 0.314, which is also significant. You cannot neglect this, because 0.314 is also having a very significant kind of a factor loading. Now come to say this one, B1. B1 is loaded on factor 1 with a value of 0.377. B1 is loaded on factor 2 with 0.661, and both are significant. If I am not putting any predefined loading value, then both are significant, because this is a very high correlation. This is a high correlation, that is understandable, but this is also a very high correlation, 0.377. Again, you come to say B2, 0.235, 0.698, 0.217, 0.772. So 0.236, 0.431, hardly any difference in terms of significance in the correlation. Now, if this is the case, then it becomes very difficult for the researcher to interpret which factor should to be retained against which variable. Okay, or in other words, we can say this is a problem of let me just explain this very quickly. This is a problem of unidimensionality. Okay, we cannot conclude that there is a single dimension being identified, because I have factor 1, factor 2, factor 3, then I have variable 1, variable 2, variable 3. Variable 1 is loaded here with 0.600, with in factor 2 with say 0.572, factor 3 say 0.019. Variable 2 in factor 1 it is say 0.118, in factor 2 it is 0.473, in factor 3 it is 0.398. These are all hypothetical, just for example. V3 in factor 1 is say 0.806, in factor 2 0.729, 0.033. Now you see these two cases, and these two cases. It's very difficult for the researchers to interpret whether to retain variable 1 under factor 1 or under factor 2. It's very difficult to interpret whether to retain variable 2 under factor 2 or under factor 1. So a dual dimension problem comes to play. Okay, but for EFA to have a perfect factor structure, identified factor structure, this unidimensionality has to be assured. Okay, now unidimensionality in these cases have not been assured, because the same variable has been loaded significantly in two different dimensions, in two different factors, factor 1 or dimension 1, factor 2 or dimension 2. So with this kind of a dual dimensionality in place, we cannot identify a perfect factor structure. So what best we can do, if I make a very simple explanation, this is like this, like say if I draw this x-axis and y-axis, say this is factor 1, this particular y-axis, it represents factor 1, this represents factor 2, this is x-axis, and these are the corresponding, you can say, correlation or the loading. Sorry, 0.4, this is 0.6, this is 0.8, and here also it is 0.2, 0.4, 0.6, 0.8. Fine. Now, suppose after conducting the factor analysis, a factor is loaded here, then a factor is loaded, say, somewhere around here. Okay, so a factor which is loading here, suppose I am talking about sorry, not factor, these are variables, say variable 1 and variable 2. So with respect to say in this case, if I consider variable 1, so variable 1 is loaded in factor 1 at 0.6. Okay, and variable 1 is loaded in factor 2 at 0.4. Fine. So what will be the distribution? Factor 1 and factor 2, variable 1 and variable 2. Variable 1 in factor 1, it is loaded on 0.600, and in factor 2, it is 400. Both are significant because they are a high correlation. And variable 2, you see in factor 1, it is loaded here, say in 0.4 area, and over here, say in 0.3. Again, these two are quite significantly loaded in both the factors. So I cannot make a decision. So what to do? Now here comes the concept of the rotation. Okay, the machine algorithm is given a command to make a orthogonal rotation. Okay, orthogonal rotation, so that the variance is maximized. That's why we followed the varimax option. So once it is rotated, suppose there is a 90-degree rotation, and if I come to this particular point, see there is a rotation of the axis. This is F1 and this is F2. Now you see this is the position, new position of variable 1. This is the new position of variable 2. Now the position of the axis has changed. Fine. So this is 0, 0 origin. This is 0.2. This is 0.4. This is 0.6, etc. Now you see the variable on factor 1. It is loaded on 0.6. Variable on factor variable 1 on factor 1. It is loaded close to 0.6. Variable 1 on factor 2, now it is loaded to say close to 0. You see, less than 1. So if it is 0.1, this is loaded somewhere between say 0.09 or something like that. Now we can make a clear-cut decision. Since I have allowed the axis to rotate, it has ensured unidimensionality. So V1 retains 0.600 for F1, and for F2, it is loaded on 0.09. At 0.09, we can easily neglect because it is having a very low correlation value. So that is basically, in a very simple way, if we put what rotation or axis rotation or factor rotation or orthogonal rotation with Varimax option, and that is the objective. The objective is to ensure an interpretable value. Because in this case, when we have two different values of correlation, two different values means 0.600 and 0.400, both the values are significantly high in terms of correlation between the variable and the factors, then probably the interpretation becomes very difficult. The interpretation is lacking because there is a issue of dual dimensionality. But to make it more interpretable so that the unidimensionality is retained, we need to tilt the axis. We need to allow the axis to rotate so that it incorporates the variable layout in such a way so that one particular variable is correlated with one particular factor in a very significant manner, and for the other factors it will gradually fade out. Okay, fade out means it will have a considerable low value, so that we can identify that particular factor which integrates that particular variable. Okay. So that is all about this particular command when you will be conducting a factor analysis. So let us go here to the dimension reduction factors, rotation that the Varimax is given, and the options over here. You suppress the small coefficient. Okay, and if you suppress the small coefficient and if you give certain inputs, say if you feel that 0.60 is adequate enough, or you can give 0.70. We have given 0.70 earlier. Let us give 0.60 now, the absolute value, and continue and press OK. Now you will find that it gives unidimensionality. You see, all the other factors were suppressed. So for this particular factor number 3, only M1, M2, M3, M4, they have a very significant loading. Say M1, M2, M3, M4, they did not load on other factors with a very significant value. So with the help of this rotation, we can actually eliminate this process of eliminate this issue of dual dimensionality. Okay. So what to report in EFA? What are the things that we need to report? We need to report the KMO and Bartlett. One more thing, since we are dealing with a particular scale, we need to have internal consistency of the scale, or what we say the scale reliability. Okay, internal consistency or scale reliability. Probably you have heard about a particular reliability term. We are not talking about validity at this particular point of time. We are considering only the internal consistency of the scale. Now, there is a very thin line of difference between reliability and validity. Reliability basically refers to the consistency part. Okay. Reliability, it basically talks about consistency of the scale. So if a scale is giving you wrong result, suppose I have developed a watch. Okay, watch is nothing but a scale. It gives time. Okay, suppose when it is actually 11 a.m., this watch shows 5 past 11. Okay, so I am taking a multiple number of measurements. Say at 11 a.m. I found the watch is showing 5 past 11. At 12 p.m. the watch is showing 5 past 12. At 1 p.m. the watch is showing 5 past 1. At 2 p.m. the watch is showing 5 past 2. So I have taken, say, a series of observations, and then I have come to a conclusion that the watch is reliable. Okay, you can rely on this particular watch in spite of the fact that the watch is not giving you accurate time, but it is giving the same inaccuracy at a given interval, the same inaccuracy. So if it is a 5 minutes inaccuracy, it's a 5 minute span that actually explains the inaccuracy. At any given point of time, it is showing the same level of inaccuracy. That means the watch is reliable. Okay, but the watch is not valid. Okay, the valid means it must show the true result. So if a watch has to be valid, it will show 11 a.m. when it is actually 11 a.m. It will show 12 p.m. when it is actually 12 p.m. So if it is showing like this, then the watch is at the same time reliable and valid. Okay, now going back to the data, we need to check the reliability of this particular scale. So that reliability means the internal consistency. So every time I apply the scale in say different context with a set of different respondent, it will churn out the same result. So what we can do is, let me put the reliability terminology that we normally refer to. It is called Cronbach's alpha. Okay, so we are actually trying to find out the alpha value. So again, the rule of thumb is alpha value, if it is greater than 0.8, it it is interpreted that the scale has internal consistency. Somebody says that if it is greater than, say, 7, then again internal consistency is registered. But many journal papers have reported that the Cronbach's alpha should have a value greater than 8 to have a better consistency in terms of its application. So what we can do is, we go to analyze, we go to this particular option called scale, and then we go for the reliability analysis. Okay, so what we are selecting by default, it is alpha. So we are putting all the variables for which we want to measure the internal consistency. And sorry, okay, let us put over here, and then just we need not do anything with this with these things. Okay, just put okay, because we are only interested to know about the Cronbach's alpha. So Cronbach's alpha over here, you can see at the bottom, it's 0.946. It's very good. Okay, so we can say, as far as the internal reliability, internal consistency of the scale, it's very good. It's 0.946. It's way above 0.7 and well above the 0.8 value that most of the journal papers they report. So when we are reporting EFA or the exploratory factor analysis in our journal paper, we need to make sure that we report certain things. Number one, we need to report the Cronbach's alpha first for internal consistency. We need to report KMO and Bartlett for sample adequacy and rejection of the null hypothesis that the matrix is a singular or an identity matrix. We need to report the total variance explained. So if we go back here, the total variance explained is 73.434. So five identified factors have explained 73.434 percent of variance in that particular model. So that is quite significant. Sometimes you can go for reporting the scree plot, but it is not required. If it is a PhD thesis that you are writing, then you can give all the results. But when you are writing for a journal paper, it's not required. If your paper is basically about a scale development, then you should report the rotated component matrix. Otherwise, you can only identify the factor structure, because you are supposed to name these factors. Okay, that is the prerogative of the researcher. Say M1, M2, M3, M4, they are loaded in a single factor. So this you can name as, this factor you can name as mobile app usage, because all I have explained is M1, M2, M3, and M4 are nothing but statements or variables that, with the help of which we wanted to identify what is the nature of mobile app usage amongst the respondent. Okay, like A1, A2, A3 that measured the attitude. So all A1, A2, A3 have been loaded in factor 4. So we can say factor 4 is consumer attitude. We can name these factors, which is very important, and these factors are to be named by the researcher. And in a paper, if your main objective is not to develop a scale, your main objective is to find relationship. That means at a later stage you will be conducting a regression analysis of various nature. There you need not go for detailed elaboration of rotated component matrix. You only give that these are the identified factor. Okay, and you should report that factor number 1 has 1, 2, 3, 4, 5, 6 items. Factor number, say, 3 explained with the help of 4 items. Factor number 4 explained with the help of 3 items. In this way you can report. So you give names of these particular factors, and within the bracket you write the number of items that was used or that were used to identify that particular factor. Okay, so these are the things that are to be reported when you are conducting a EFA. Okay, so I do not think that we will be having time for the CFA, but let us just take a very quick look for the confirmatory factor analysis. In case of a confirmatory factor analysis, what we do is we actually validate that measurement model. Okay, we have found a measurement model, and then we validate. That means we want to identify the construct validity, the convergent validity, the discriminant validity, etc. That we want to do. But you see, although this workshop is Dayada, are you there?
Yes, sir. Yes, sir.
Can I just take 5 minutes more?
Sure, sir. No problem.
No, actually, I want to show you another software, not this SPSS, because you have understood what SPSS is all about. Because in this workshop, you focused on two things. One is an open source software called R, and the second one is a proprietary software called SPSS. I will show you one more software which conducts EFA and CFA simultaneously. Because if I want to conduct a CFA, obviously SPSS will not help me. You need to find out another adjunct software which is an extension of SPSS, which is called AMOS. Okay, so IBM AMOS is required for conducting this confirmatory factor analysis. You cannot use the normal SPSS. But there is a software you can use it because they are offering the trial version. You can use it for 1 year. So if your data is absolutely ready with you, I think 1 year time is more than enough to conduct the entire analytical part. So that particular software, probably also that software, you have heard about that. And the name of that software is Adanco. Okay, just allow me to write the name. There are certain advantages of Adanco, as I have told you. The name is Adanco. Okay, the main advantage is it uses Excel file, not the .sev files or SPSS file. Now it is much more easier to use Adanco then, because if you do not have SPSS, it's not a botheration. So if you have an Excel file, the same data set that you are using in SPSS, the same data, if you are having in Excel, you can use it. Let me just quickly show you uh, so that you will have a preliminary understanding. This is, if you can see this icon, this particular icon is of Adanco. You visit the website of Adanco, then you can easily download it. So double click it to open, and there are two options: open an existing project, create a new project. You simply click create a new project, and say I'm giving a name, say demo. I am just storing it at my desktop. Save. Okay, now this is opened. Fine. So this is the first construct. You just delete it, and then it is a big canvas. Okay, now, as I have told you, this Adanco reads only the Excel file. So let us use the same file that we have used for this SPSS. I have used the SPSS file. Now I will use the same data in the Excel format. So this is the file or the project, and then edit, then run, then results, view help. These are the navigational tools. So let us go to this project, import data. Okay, just click it. So what I have done, I'm just quickly recapitulating. I have gone to project, import data. Now it will ask me to choose. So click choose. In the desktop, probably I am having that same data. Let me just probably this one, or data set. Let me just have a quick look in which name I have saved it. Then I will just go for that. Probably this one. Yeah, this one, data set. Fine. So project, import data, choose it, data set, open. Okay. So you see the entire data set is exported, and it will say that there are 169 observations with 0 cells with missing. So there is no missing value. So in this entire software will immediately identify whether there is any missing value in any cell, so that you will be immediately knowing the fact that it is an incomplete data set, and you can easily impute it. Okay, wherever there is a missing data, you can impute it. Okay, so now you just follow the command. You click next, next, and then finish. Okay, so on the left hand side, you see the entire loading has been made. All the variables from M1, M2, M3, M4, A1, A2, A3. So this is the mobile app usage, this is the attitude, then loyalty, satisfaction, this is the brand experience and brand attachment. All these things have been, all the variables have been loaded. Now what you have to do, you see, very simple. You select M1, then you select after pressing shift, you just select the other three. So M1, M2, M3, M4, these four items are supposed to explain the mobile app usage. So you have selected, and you simply drag it here. You see, your task is done. Okay, let me just zoom it a little bit. You see, the moment you dragged it, the entire loadings have come. You need not do anything. You have to just select it and move it to this area. Okay, so the factor analysis that we were talking about, the factor analysis, the factor loading is done by simply selecting it. And as I have told you, that when I am creating this initial model in the confirmatory factor analysis, we are actually developing the measurement model. In the EFA also, what we have got here, say for example, if I go here, what we have got here in the form of rotated component matrix, it is the preliminary measurement model that we have got. Okay, the initial scale development that we have got. Fine. But in case of an adanko, what we can do is you can rename this a particular construct. You can select this particular construct. You can move at any place, and you can actually rename. If you right click it and then remain it, since it is a mobile app usage, say I am giving this particular name MAU, so it will be renamed as MAU. And then I have another construct at the bottom called brand attachment, say BA1 to BA5. These five, so I am bringing it here, and if I right click it, I can rename brand attachment, say BAT. So over here, if I just right click, I can change the indicator's position to the right, so it will go to the right hand side over here. And then I have the brand experience from B1 to P9. Okay, so let us just stick with these three factors. So I can rename this as BEXP. Okay, so this is my factor 1, this is my factor 2, this is my factor 3. These are the factor loadings we have already done in the SPSS. Okay, so in SPSS we have 2 more factors, but here we are restricting ourselves into the primary 3 factors. Okay, so this is the brand experience, this is the number of factor loadings, this is the number of factor loadings for mobile app usage. So EFA is done. Okay, we need not have to calculate it in a different way. The EFA is conducted. Now, for the CFA and for the model. Okay, so if I go back to our older, PowerPoint slide, probably, let me see whether I have used, yeah. See, I have shown you that this is our theoretical model. Mobile app usage, it is influencing, it is having an impact on brand experience. Brand experience is having an impact on brand attachment. Mobile app usage is having an impact on brand attachment. This is the theoretical model that we wanted to test. Fine. So this particular arrangement has been done here, isn't it? This particular arrangement has been done here. So now what we have to do, we have to, draw the regression path from here to here. Now, the moment I am drawing the regression path, the regression analysis is completed. It is as simple as that. See, I have drawn the line, the regression coefficient appears. I have drawn the line, the regression coefficient appears. I have drawn the line, the regression coefficient appears. I need not go for any other test. See, the confirmatory factor analysis for the structural model is also done here. So with the help of this particular software, the EFA, CFA, the structural equation modeling, the mediation, moderation, whatever test, it is done at a split of a second. Now, one important thing over here is, see, the regression coefficient is 0.330 over here. It is 0.261. It is 0.605. I simply do not know whether these values are significant or not. Okay, because when we are conducting a regression analysis on the SPSS, there is a marking of, say, a star mark, which indicates at what level the significance is. So what I can do to identify whether these values, these beta values are significant or not, I will simply click this run option. At the top, you will see this run option. Okay, so the moment I'm clicking this run option, a box will appear, and there are 2 sets of randomized figures to be generated. One is this random imputation seed. You need not have to do anything. You just click generate. So a figure will be generated, and then the bootstrapping. You simply click generate, and again there will be a random number being generated. So what you need to do is to click this, use bootstrapping. Use bootstrapping means this particular process will conduct an iteration with the existing sample number. Remember, I have used 169 sample numbers. So there will be a constant iteration, different proportion of the sample, different proportion of smaller samples will be used from the sample base and assess the model fit. So I need to check these 2 boxes. One is use bootstrapping. The second one is assess the model fit. And you need to just click save and run. So the operation will be conducted, and depending on the your configuration of the machine, either it will be a bit slower process or it will be a bit fast. Now you see the star marks have appeared, so it is 3 stars. That means it is almost 90, it's almost 99% significant. Had it been 2 star, it would be between 95 and 99, and just 1 star, close to 90, 92%. And if it is no star is appearing, that means it is insignificant. That is, it's not over 90%. Now, another interesting thing, that we are assuming that mobile application usage is having a direct impact on brand attachment. Fine. We are assuming that mobile application is having a direct influence on brand experience. We are further assuming that brand experience can create a mediation impact between mobile application and brand usage. So in the presence of a brand experience, the impact of mobile application usage on brand attachment will increase. So you see, for the time being, I am just deleting this particular relationship. Now you see, impact of mobile application on brand attachment, the R square value is 0.486. Okay, so what does this signify? This signifies that 48.6% of variance in BAT is explained by MAU. 48.6% of the variance of brand attachment can be explained by mobile app usage. Okay, now let me draw this mediation effect. You see the R square value changes to 0.539. It has improved, isn't it? Now the variance is much more. Now that means more variance can be explained. So we can conclude that definitely there is a mediation impact. Initially it was 48% of the variance could be explained. Now we can explain 53.9%, almost 54% of the variance that can be explained. So we can conclude that there is a mediation, but whether there is a full mediation or a partial mediation, that can be explained by considering variance accounted for. That's a different formula. And I will just end this particular session with one thing, that I have conducted all these tests, but where are the results? Okay, over here you will find that there is a button of results. Okay, you can see here, just click it and show result. It will be an HTML file. Okay, show result. It will open a window, almost like opening in a separate browser. So this is the report. Okay, the project information. Okay, the project name is demo, number of observations 169. It will have a very beautiful reporting. See, this is the model that I have created, graphical representation of the model that was created in Adanko. This is the output. Then you have the overall model, the goodness of model fit. You will have the SRMR value over here. Then you have all those things that you require, the Cronbach's alpha, factor wise construct reliability, convergent validity. You need not calculate it separately. Discriminant validity, the heterotrait monotrait ratio, the HTMT ratio, it's there. The discriminant validity, the Fornell arc criteria, it's there. Then the factor loadings, it's calculated. The indicator reliability. Then most interestingly, you will find, let me go down. Yeah, the standardized construct scores. Now, what is the standardized construct score? See, in this particular data set, see M1, M2, M3, M4. Okay, now these are 4 separate variables. Now many scholars, they ask us that, sir, can I represent M1, M2, M3 and M4 with the help of a single variable, which will allow me to conduct certain regression analysis or any other kind of analysis? Can I represent, can I create? Many of them, they do what? They try to get a mean of this, mean of this, mean of this, and then the mean of everything. They call it a very composite mean or grand mean. But when I'm conducting or when I'm taking the mean, it is not standardized, because I am not fixing a weight to standardize this. Okay, so what Adanko does, it produces standardized construct scores. So over here, the question of my scholar was, M1, M2, M3, M4, this actually represents the mobile app usage. That is the factor. Okay, so I have respondent of M1. I have respondent on responses from the respondent from M2, M3, and M4. But can I combine them to create one particular response score for MAU, the factor? Okay, so Adanko does that. You see, this is the imputation scores, and you can use it as a single score for all the 169 respondent. Okay, this is the weighted mean score. Now, with the help of this particular score, you can conduct certain regression analysis between these three variables, MAU, BAT, and BEXP, because MAU is the independent variable, BAT is the dependent one, and brand experience is the mediation. So you can conduct the test by simply using this score. So that is too good, compared to, we used to have this regression, this SPSS, but ever since I have started using Adanko, things are much more easier. Okay, so let us end this session. If you have any question, you can ask.
Thank you, sir.
Hmm.
So, any question, any confusion, any additional information? No. So, thank you, sir. Thank you all the
Thank you very
participants.
much.
So, let me participants, thanks for your uh, being with us for 10 days. Though a few friends informed me that they have the vaccination date, that's why they have not joined. And I will send the certificates to after receiving your reports. So as allotted the reports discussed 2 days ago, just a change. Borun Kumar Maji was not allotted any session. So please, Borun,
Yes, sir.
write report on Professor Gautam Bandyopadhyay's presentation.
Okay,
Okay.
sir. Okay, sir.
And Sunandana, you can write on Dr. Samiran Sur's presentation. Okay.
Okay, sir. Okay, sir.
Krishna sir, you can write
Yes, sir.
28th February, Dr. Suresh Sharma's presentation.
Thank you, sir. Thank you, sir.
Okay. So please, others are not here, so I am not able to allot. Anyway, I will send them the assignments.
Sir?
Yes, any question?
This is Sunandana. For me, it's Dr. Shomiran Shur, right?
Yes, yes, yes.
Oh, okay, thank you.
Okay. Hope, I don't know how much you have taken the input, but expecting that at least 10% you learn from the workshop. So if any you need any feedback, want to give in through mail, send us through mail. Okay, and all reports should be in Word file. Don't send in PDF. Okay, thank you all. Thank you.
Okay, sir. Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.